Hi, everyone. I'm Lori DeToro, Communications Manager for Turntide Technologies. Thank you so much for joining us today to learn more about safe, high-powered lithium-ion batteries. We are thrilled to have George Patterson presenting for us this morning live from our Gateshead manufacturing facility in Gateshead, UK. Thanks so much for joining us today, George.
You're welcome, Laurie.
Excellent.
Okay, good morning,
Before
good
we
afternoon,
hang on
good
just a
evening,
minute,
wherever
George,
you may be calling in
I'm
from.
gonna give some housekeeping stuff first, and then we'll get started. We have some housekeeping. This presentation is being recorded and will be available on demand on the Current and Wave website within about 48 hours. We will be taking questions at the end of the presentation, so please use the Q&A section to ask all your questions anytime during the webinar, and we'll answer as many as possible. We also have a link. We do not have a link for our July webinar, but you can find that on the Current and Wave website. Go ahead and register for that when you get a chance. Remember, this is a live event, and when we mess up, and I just did, laugh along with us. And that's it for housekeeping. Remember to ask your questions, and George, please take it away.
Okay, thanks, Laurie. Welcome everybody to the call today. This is one of a series of webinars that we've been doing over the last few months, focusing on some of our product lines. So today I'm going to speak to you about our range of battery systems that we have, modular packs. But first of all, just a little bit about who I am. So my name is George Patterson. I'm VP of Product at Turntide. I've been with Turntide now for 1 year, but previously worked at Turntide a few years ago as well, so in total about 2.5 years. My experience goes back 40 years in design and manufacturing experience, with 26 years specifically with lithium batteries, either designing them or selling them or now in the product role. So I have a small but dedicated team of product heads who look after the different product lines for Turntide. But today I'm just going to cover battery systems for you. So on the agenda we have a couple of slides on Turntide overview, so that'll be quick and simple. We'll then dig into what our modular battery system is and what it does. We'll look at some battery requirements. So again, anybody familiar with previous webinars I've done, I always like to focus on battery requirements. Then we're going to look at the battery regulations. Again, I think this is an important aspect that I've again mentioned a few months ago. We're going to reiterate that and actually show you that live in a real product. We'll show a case study of how we got from where we were 9 months ago during the development phase to actually where we are now, where we have real live products in front of us. And then we'll wrap up with a summary at the end. And then we're going to have a product walkthrough. So I'm going to tell you all about these black boxes that I have in front of me. Okay. Okay, so an introduction to Turntide. Again, if you've been on any series of webinars that we've done, you'll be familiar with this slide. But for those of you who are new, it's great to see some new people online. Turntide Electrification really comes from three companies that were merged 4 years ago, all based in the northeast of England and the UK. They were Borg Warner Gateshead, Avid Technologies, and Hyperdrive, all based within 30 minutes from each other. And those three businesses were very attractive to Turntide because they all had an end goal of working in electrification. So Sevcon has the longest history going back to the 1960s. So they were developing early power electronics for electric vehicles, i.e. milk floats, forklift trucks, etc. And then developed those into a wide range of products for things from commercial vehicles to supercars. Then Avid Technologies, again, started about 2008. They were working on the development of axial flux motors, cooling fans and pumps for electrification vehicles. And again, a lot of traction in commercial vehicles and industrial equipment, construction equipment, and again, also supercars and hypercars. Around about the same time, 2008, Hyperdrive came to being as well. So Hyperdrive were lucky in that they were able to access cells and cell modules used in the Nissan Leaf. The Nissan Leaf was manufactured literally 1 kilometre away from where the battery company were set up, Hyperdrive. And by using those well-proven and tested modules, we were able to then develop batteries for autonomous guided vehicles, for construction equipment with JCB specifically. And we also used that same chemistry and technology in a train application. So we went from something that's very quite small, low voltage, up to a train application that's 2,500 volts using the same cells and chemistry. So really those three businesses were a match made in heaven for Turntide. They were not overlapping. It was very, very complementary to bring these businesses together. So that's a little bit history. It brings together about 60 years of electrification. We have somewhere around about 300,000 vehicles on the road and growing every week. And lots of experienced engineers and people within our business. Okay, so what products do Turntide make? So hopefully some of you online will be familiar with what we do. In case you're new, this is the products we make. So leading edge axial flux motors, it's a new technology. We've done various webinars recently about this. So please look back at our, the previous webinars we've done. And Adam Nixon will give you a really good update on axial flux. Low voltage inverters and high power inverters. Again, we'll be planning a series that will be going through those products in detail. We have fans and pumps, which actually just behind me, we actually manufacture the fans and pumps. So we're actually live on the production floor here at the moment. And what I'm going to talk to you about today is our modular battery pack system that we have as well. So again, all very complementary products in our product line. So let me just touch on this, and I'm just going to give a quick overview on this slide because I'm going to go through this in detail. So this is again a good slide for reference. So we have what we call our Generation 5 modular battery pack. We have two versions. We have a 4.5 and a 6.8 kilowatt hour system. Both of them are running at 44 volts. Both of the packs can be connected in series and parallel to give different capacities and different voltages. We've got various features, which, as I said, I'll go through in detail a little bit later at the end of the presentation. We've made various improvements from our Generation 4 pack. The format has changed slightly, the energy density has increased, and we've just used the latest cells that have been available on the market. And I think the important thing for today is the fact that battery regulations have become so much more restrictive, which is a good thing. It's making batteries safer for the marketplace. So our packs are now compliant with the latest CE regulations as well. And I'll talk you through some of the features that we needed to implement on these packs that were a little bit different from our previous pack. We also have our Gen 5 BCU, so battery control unit. So again, I'll go through that in some detail, but that's really an independent control box that really pulls the information from the individual energy storage units and outputs that information into a vehicle controller that can control contactors, etc. So I'll cover that in a bit more detail later on. The modular pack, again, from a specification point of view, I won't read through every line. This is available to download on our data sheet, all free to access on our website, where you'll get all of the details and more. So this is really just to give you a summary of the packs that we have. As I said, we have two sizes. So it allows you to build, gives you a bit of flexibility in the products that you build through. 100 amp, 150 amp continuous charge currents on both of these packs respectively. The weights are on there as well as the gravimetric and volumetric energy density, which are competitive in the marketplace, considering that these are CE approved as well. So I'll go on to explain that. So again, good temperature range across the board from -10 to +50. So and the IP rating on both of these packs is IP66 as well. I think one of the things that I want to emphasize is the cycle life. So this chemistry is NMC. So that traditionally has not really been that renowned for long lifetime. But we did extensive cell testing over a very, very long period of time to find the best cells and the best cell modules that we can. So that allows us to look at this from a cell level, not from a modular level, but from a cell level, that we have 3,340 cycles down to 80% of the original capacity, which we believe is very good. And we've got the test data to back that up. It's not just extrapolated data. Let's put it that way. Okay, Laura. What I wanted to cover was some of the benefits of modular batteries, because I think there's been a lot of market shift. Recently, there's quite a lot of companies do custom battery solutions. And we also do custom battery solutions. But we also have, this small range of modular packs that provide a lot of flexibility and scalability in the marketplace. Specifically because we're having to do so rigid testing to be able to CE mark these, then from our point of view, it makes sense that we focus our efforts on these two battery sizes that can then be configured into a larger system, and the end user or the OEM don't have to worry about getting the CE certification and all the bump vibration testing, cell propagation, thermal propagation testing done. We've done that all in these individual modules, and then all the OEM or system integrator has to do is connect these together. So from a flexibility point of view, being able to put these into industrial applications, into construction equipment, etc., we've got a proven track record in our previous modular battery packs of working very well in that marketplace. So I think flexibility is a key thing. Serviceability, maintainability, with future requirements where we don't just want to be a throwaway society, we want to be able to service. We've made sure that our packs, our BCU and our modular packs are very serviceable. They're not user serviceable, they would be serviced by us. But if there was any issues, we can swap out BCUs without having to ship the whole energy storage system. So again, that's a benefit. If there are any issues out in the field, swapping over modular packs and swapping over BCUs is a lot easier. Cost and time efficient. So I'd like to say we've done the hard work. We've been developing these modules over a number of years to get to where we are today. So proving the life cycle on the cells, proving the safety, thermal propagation, bump, vibration, IP ratings, etc. So we've done all of the hard work. So that really means that we can supply these straight off the shelf. We can supply these to customers. They can be up and running within a few weeks, getting a system, getting some wheels spinning or tracks spinning or things moving, whatever the application is, propellers moving, whatever. So, given time and cost to market, if that's really critical, then again, using modular packs is actually quite a good place to start. High performance, they're designed to meet, environmental standards, so from dust, shock, vibration, etc. So, these are pretty high performance packs. They're not the most rapid charge, they're not the most rapid discharge. But for the applications that we've designed this for, the performance is very good in these battery packs as well. Future-proofing designs. So again, as technology advances, we can increase energy density on these modules. We can work with OEMs, we can work with system integrators and any future upgrades in the technology that will come. Cell technology is changing all the time. So again, by keeping these pretty modular, then that allows us to enhance, as battery and cell chemistry improves, we can implement those changes relatively easy within our system. And sustainability, again, as I mentioned earlier on, the flexibility and scalability, being able to recycle, so being able to reuse. So in theory, we can take the modules from these packs, they can be reused in other applications, maybe for grid storage or for solar energy storage, etc., renewables. We can then take those modules that maybe need to go for recycling after second life use. We can recycle all of the metal housings, etc. So very sustainable, very high level of sustainability, reuse of the materials as well within these packs. And again, this just shows some of the applications. So anything from mini diggers to construction equipment, diggers to agricultural to autonomous guided vehicles. these packs are really a good starting point for battery design. Okay, battery requirements. Again, I like to kind of cover this. So although this is our standard product line, what we did is we listened to customers, we had input from customers, feedback. We've got certain target applications that we're looking to get these packs into. So they're not really designed for kind of aerospace applications, but they're certainly usable in industrial applications, agriculture applications, as I mentioned. Then thinking about duty cycles. So again, this is not particularly heavy duty cycle. I would say this is light to medium duty cycle, but that again was the requirements that we were working to. We designed this pack with future regulations in mind, so looking to get to the latest EU battery regulations and being able to apply the CE mark. And then other features, things like LEDs on the front to warn of status, having features on the BCU to control external contactors, etc., to give the customer flexibility was what we're looking at. Cells and modules, again, that was a vast part of the development process. We literally spent months assessing a wide range of suppliers for cells and cell modules. So in these particular batteries, we buy pre-configured cell modules because they were readily available. We chose a VDA 355 modular size because that was standard certainly a number of years ago. And we have access to several suppliers who can supply VDA 355. So it gives us that flexibility. Format, we went for a flat format so that we have at least one dimension that's quite small, so that this can fit into smaller spaces, tighter spaces, etc. So again, our last battery system was much more kind of brick-like, if you like, a bit more kind of cuboid. We decided in this version it fitted well with the modular types that we would make one of the dimensions a little bit smaller. So again, that works for a lot of our customers. Power and energy, again, we've designed this for energy. We're using the capabilities of the NMC chemistry to deliver energy. We're not trying to deliver necessarily high power in this. And we chose the NMC chemistry. We'd used it in the past. We've had a fantastic safety record with NMC. We've got a really good quality BMS managing those cells, and we buy cells from a quality supplier. So no problems with NMC. We will probably look at other cell chemistries in the future, maybe fitting into the same format or maybe being a different variety. But certainly for the customers and the target market, NMC is actually a good fit for these products at the moment. Again, a whole list of standards. So again, this is pretty daunting. So if you're starting to design a battery, this was some of the requirements we had from a specific customer. There are many, many more. And trying to get your head around all of these regulations is pretty time consuming. So again, my message is we've done that for you in designing these packs. You don't have to worry too much about these battery regulations because our packs meet the regulations and customer requirements. Yeah, battery regulations. So again, this covers some of the topic that I covered really kind of a few months ago, but I just want to re-emphasize this. Simply because timelines are getting really tight now. So again, going back a couple of years when these regulations were first thought about, it kind of seemed a long time away, 2025, 2026, 2027. But now a lot of these regulations are on us, and some of these regulations kick in from August. So I just want to kind of run through some of these as well. So as I say, the regulations started to apply in February 2024. Until August this year, on the 18th of August, we've got regulations coexist with the existing battery directive. From, well, really just a couple of months from now, really, the regulations are going to be the full new battery regulations. So again, there's been a little bit of a grace period, a transition period. They're coming to an end. So when you're choosing a pack supplier or battery supplier, you want to make sure that they comply with the latest battery directives. Thinking about, so we specifically wanted to get Reg 100 so that we could have these on road-going vehicles. So again, from a vibration point of view, from thermal propagation point of view, we were trying to pick the best from the Reg 100, the IEC 60068 regulations, to try and amalgamate those regulations, find out where there was synergy, where there wasn't synergy, we would take the tougher regulation to have these passed as well. So these packs have, comply with the ECE R100 regulations, latest version. This allows us to put CE marking on, and CE marking is pretty important. CE marking applies to many products, whether you buy a laptop or a TV or a refrigerator. You'll find that CE marking applies certainly for the European Union. And really, to summarize that, that means that the product meets the regulations required for that particular product to be sold in the European market. So it isn't really saying, here are the regulations for CE. It's really saying, you understand your product, you understand the market, you understand the regulations that apply, and you apply those regulations. So again, a lot of work and effort has went into designing these packs and having them pass all of these tests so that we can put the CE mark on these products. We went through a lot, risk assessments, technical documentations, doing pre-compliance testing before we go and spend money at external test houses. So again, we've used local facilities to do thermal propagation. We've used in-house vibration testing just to really prove out the design. And we've also had these packs away at external test houses as well, so that we can get test reports, and that allows us to apply the CE mark. So we have all the background material that we need to be able to put the CE mark on these packs. Yeah, again, there's really a lot to this. As you see, you go kind of through all of this. So being able to apply CE marking is only going to get tougher. The regulations are changing. So, we need to think about, recycling. We need to think about our carbon footprints. We need to think about the risk. We need to look at our manufacturing processes. So it's not just, energy that goes into the materials. It's also the manufacturing process we have. And, those regulations are getting stricter and stricter all the time. As we said, we need to check batteries conformity. So we need to go and spend money and have these officially tested. Now, when you've got a couple of battery variants, that actually starts costing quite a lot of money to do this. So we've invested a lot of money into these two products so that OEMs and system integrators don't have to do it. We've done the work for you. So one thing that we're looking for, that the battery passport part of the regulation as well. So these packs will have QR codes, will have traceability on these. So although the implementation date is not until February 2027, we are working at the moment on systems in the background to collect the information required for a battery passport. So that's like things like, what are the materials inside the pack? What was the cell chemistry? When were the packs made? What are the raw materials? What are the recycling instructions that go with this as well? So this is something that whoever ends up with this pack in the future should be able to scan a QR code, and that links them to an electronic record that always travels with the battery pack. So, that's really a good thing, I believe. So we're putting that in place. We're going to implement this before the date that is required. So watch this space, and maybe we'll have a specific webinar talking about battery passport and regulations in the future. This is one thing that really has come up, and it's actually coming up fast with us as well, and that the supply chain due diligence obligations. So we, as a battery pack maker, we need to do our due diligence. So we need to look at our whole supply chain on cells, and to make sure that there's no the materials are coming from basically sustainable resources or good resources, that there's no child labour involved. So that's actually quite an undertaking. We need to pass a lot of this down to our supply chain as well. But again, this is quite a big task. So our legal team are working on a due diligence policy, which we'll have up online on our website in the next month or so, The deadline for implementing this is actually August this year. So that's coming up on us very, very quickly. So again, we take our responsibilities very seriously. So again, for those of you out there who are thinking about designing packs or choosing a pack supplier or battery supplier, please consider this. Please consider some of these regulations and make sure that your suppliers comply with this, because there is a lot of work involved in doing this. Yeah. And again, this just mentions about thermal propagation. So again, for the Reg 100, as I mentioned in my last webinar a few months ago, this is something where we had to make sure that in the event of a thermal event within a cell, that there was a 5-minute warning from the battery management system highlighting the warning to the battery pack still remaining safe. So again, near the end of the presentation, I'll show you a couple of pictures about how that actually worked out for us. And I'll point out the key features when I go through the product in detail. Again, just a very, very good summary of when these regulations get implemented. As you can see from the slide, that basically every year for the next few years, there's increasing requirements for the regulations to be implemented. So we're really at Turntide trying to be really proactive here and really get ahead of the game, not wait until we're right up against the deadlines to do this. Because we believe these products have a good lifetime ahead of them, so we want to make sure that they comply now and not be in a situation where we can't sell product into the marketplace. So we've been very proactive on this front. Again, really just to kind of summarize this, I think and again I mentioned it previously, that these new regulations, that they're quite challenging. It certainly increases the cost of doing compliance. We need to look at technology and we need to look at solutions in a slightly different way. And again, I'll point that out very soon, some of the probably extreme measures that we had to go to here. Manufacturers are needing to adopt quickly. They need to gain the experience, but once they have that experience, then I'm pretty sure they can gain a competitive edge in the marketplace. So being compliant, understanding the marketplace, understanding the regulations is really key. Just being able to put cells into a metal box is no longer really good enough, I'm afraid. So I think the EU regulations, whilst increasingly tough, I think being in the battery industry for 26 years, I'm really pleased these regulations come in. So I think it's going to be a case of the people who comply will be successful. The people who don't comply, I'm afraid, are probably just going to disappear and drop off. So. And again, thinking about the circular economy and thinking about renewables, and again, a lot of the regulations, it's not just to kind of think about safety, it's to think about things like second life use, reuse of materials, being able to put materials back into the supply chain again. So again, the regulations are going to look at in the future how much recyclable material is involved in our products. And that's going to be targets that's going to increase. So again, we can't just put these to landfill. We've got to second life use where possible, and then have efficient recycling. We don't just want these going to landfill. Okay, case study time, and then after this, we'll start looking at the product. So I think, yeah, we could probably. So as I said on this one, we had to do the compliance testing to make sure the battery pack would last for more than 5 minutes. So next slide, please, Laura. If you could go back one, please. That's okay. There we go. Perfect. So what we had to do is we actually had to have special modules made so that we could instigate a fault within the cells. So we had little heater elements going in there that once we set up the test, we instigated a fault which caused a thermal runaway in a cell. And then we looked at how that worked out when we applied that to a pack. So next slide, please. So if we go back, probably 9 months ago, we had a design that was a plastic housing. It was a plastic case. And when we tried to pass these regulations, we found the plastic case was melting. We had gases venting from, all different sections, till eventually that combined with oxygen, and then we actually had a melted case, and we ended up with a battery fire. Now, by that time we'd instigated a fault within the pack. So what we did is we kind of went back to the drawing board, if you like. We still used the same modules. We still used the same electronics within the pack. We moved to a metal construction of housing, and I'll go through in detail with that. And then the results are radically different. So when we look at the results there, we actually then got to the point where, again, doing exactly the same test over the same time period, we were able to control the release of gases. We have very little smoke. And when you look at the end of the test, that that pack was running, we left that pack running for a few hours just to let it settle down. And then there's hardly any significant damage to the case at all, because it's all controlled through the vent that we have on the front of the pack. So again, complying with the regulations, we had to go down this route. We had to go down the route of the metal case. We had to make sure it was sealed. We had to make sure that we controlled the release of gases. Okay. So, in summary, yeah, new battery regulations, they're happening now. People need to be aware, if you're buying batteries, you need to be aware that these regulations exist and that you comply. And a good partner for you is going to be someone who understands these regulations and whose products actually comply with that. Alrighty, I think we're just going to swap over to the camera shot now. I'm going to take a quick drink. Okay. Right, I'll actually start. I'll pull one up from under the bench. I'll actually start with our battery control unit. So our battery control unit, if you like, this is like the master battery management system. So what we do is we hook up the individual energy storage modules. We hook them up to what we call the BCU. There's various inputs and outputs. So one of them daisy chains all of the packs together, and the other one allows multiple inputs and outputs to a vehicle controller. We can control contactors for pre-charge. We can control contactors for switching on thermal management or cooling systems if that's required. So again, very simple EMC proof box, metal housing, standard box, 3 connectors, pretty much plug and play. And we also have an earthing point on this as well. And again, important CE marking that we have there. So again, this gives flexibility. So this can be put, various places on the application, and it increases flexibility. It also means that should there be an issue with the battery control unit, you don't have to return any of the battery packs. All of the electronics, the smart stuff's contained here. This can be returned. We can ship out a spare one, next day delivery, simple plug and play, and then your system could be up and running as well. So again, our previous battery packs had the master controller in each of the modules. We've taken that out and we've separated it. So again, from ease of system integration, serviceability, maintainability, spares policy, going down this route makes it far easier to work with the batteries. So next, hopefully you can see we've got a stack. So we've got the 4.5 module on the top, and we've got the 6.8 module on the bottom. The only difference is the width. So the height and the depth is the same, and all of the controls are very common. So the only thing that changes is we have 2 VDA 355 modules in the small one and 3 VDA 355 modules in the bottom. I'll focus on the top one because it makes it easier to look at some of the features. So we've got some Amphenol connectors. So we've got 2 power connectors here, positive and negative. These can be daisy chained, so we can connect these in series in parallel. just by changing the wiring harnesses, and these can be daisy chained together. Obviously, you wouldn't do it with two different pack sizes, but in theory, you just link the positive, negative, and you can daisy chain the packs together. On this side, again, daisy chain concept. So all of the modules can be daisy chained together with an input and an output on these M12 connectors. So they link back, they feed all the information from inside the pack on temperature, voltage, and current. So the status within the module all goes back to the BCU, battery control unit, where all of the state of charge, state of health calculations are made. An important feature that we had on this version of our product, rather than that superseded the Gen 4, was this is a simple black box, and you don't really know what's going on. It doesn't really make a noise, or it shouldn't make a noise. So we've actually fitted an LED on this, so it's a tricolor. So we can indicate by different flashing scenarios, whether it's green or red or blue, and different combination of flashing and rate of flashing, we can indicate if everything's okay, whether there's an issue with maybe low state of charge, maybe over temperature. So again, you don't really need to hook this up to a laptop to find out what's going on. You can actually look at the LED. That's going to give you a good indication of what's happening. Certainly, you can then hook up a laptop to get more detailed information. But if you've got an array of these all in a system, very easy to go in and see if there's a module that's causing an issue. You could isolate that very quickly. So again, serviceability, maintainability, thinking about the user here. So we've got this LED, which is a very useful feature. One of the things that makes us pass the stringent testing on thermal propagation is we've fitted a blowout valve here. So as well as this acting as a pressure relief valve as well, pressure equalization valve, this will activate at a certain pressure once. So if there is a thermal event happens within the battery pack, the pressure, the temperature builds up, the heat builds up. This will actually blow out at a safe pressure. It's all controlled, so all of the direction, we know which direction it's coming from. So when we work with system integrators or OEMs in integrating our modules into a system, we can advise where to position these modules. Now, we've actually tested this on the front, we've tested it on the side, and we've tested it on the rear face as well. So we can actually have this on different faces, on 3 different faces, if that helps the integration into the product. So really what we're trying to do is design a system so that if there is an event and there is gases coming out, that these are directed away from the passenger cabin or directed away from where someone is maybe exiting a vehicle. So again, this is a key design criteria when we are working. So our applications engineers work with the end customer to look at the best place that we could mount these. As standard, it comes on the front face, but we have the option to change that around if we need to. So again, being able to pass the test, having this pressure vent in here has been absolutely key to us being able to pass these. Looking at the top face, you maybe look at this and say, wow, what we're doing here, we've got a lot of screw fastenings. And I must admit, when I look at this as well, when the engineer said, yeah, look, we need all these screws. And yeah, it's true. We did the analysis, we done simulations, and then the proof of the pudding was actually in doing the testing. So we've got a case which is a welded case on the bottom half, and we have a lid, a one-piece lid that goes on after the modules and all the rest of the internal assemblies have been connected up. And we have a gasket in here, which is maybe quite hard to see. So we have a gasket in here that survives the temperature, it survives the pressure. But really, to survive the pressure and to allow the vent to do its job, this is really the number of fastenings that we need on the top to make sure that there's no chances of leaking any gases at any other part other than through the vent. So it looks a lot of fastenings, and I'm sure the production operators have probably some concerns about adding these, but that's what we needed to do to get this pack CE marked and passed. So Other features that we've got, so these packs can be mounted really in any orientation. We have a few mounting points. So we have 4 mounting points on the top face that we could securely screw down. These are M8s. We also have on the base, we also have 6 mounting points that you can fasten this and secure it. So we have some mounting feet on the base. These can really be mounted flat, they could be mounted vertical, they could be mounted on their side. We've done all of the validation testing on all of these different orientations. Probably not best to kind of mount it like this, or it'll be a bit complicated. But really it's flexible. So, you know, we could mount this at any angle, any different access, which gives it really good kind of flexibility here. You know, we label it all up. Again, all the labels comply with the regulations, explaining safety, don't remove the covers, etc. These are all specially tooled. What else have we got? Again, everything complies, don't throw it in the bin, etc. All of the labeling complies, and we've got a couple of earthing points here as well. So again, from a flexibility point of view, you know, whether it's better on the right or left-hand side, or maybe you need 2, if you're daisy chaining the earthing cable, then we have those couple of earthing points there as well. CE marking and QR code on the side. So, you know, so we've got traceability and we've got our CE marking on the side there of the pack. And again, we have it on the other side so that it's visible in different orientations and installations as well. So, I think I'm just going to quickly look down my notes and see if I've missed it. Yeah, so these are rated to IP66. So again, that gasket, as well as containing any pressure, which I think is, I wrote this down, is somewhere around about 4.5 psi. Is the pressure that the vent operates at. That's really as much as I could say. Inside, we have 2 modules, as I said on this, VDA355. We also have our cell monitoring unit, so we have electronics that measures temperature and voltage of each of the modules, multiple locations within the pack, and as I said, those feed back to the BCU. So this is our Turntide modular packs, 4.5, 6.8 kilowatt hours. I think I've covered most of the features that's on it. How much could you talk about a black box? It doesn't really kind of do that much. But I know from the team of engineers, designers, test engineers, validation people, the guys who read through all the specifications, the amount of work that goes into this is tens of thousands of hours and blood, sweat and tears in trying to make this happen. So, you know, it maybe doesn't look much, but I know all of the effort that's went into making this product over the last couple of years. So this product is available now. We've launched it at the Battery Show a couple of weeks ago. We've got a whole list of sales guys that you could contact for different verticals. So if you're in defense, if you're in marine, if you're in construction equipment, agriculture, we have relevant sales guys that can talk you through. We've got a very good set of applications engineers who are your technical port of call within Turntide. So again, if you need help with how do I install these, how many do I need, you know, what chargers do I need to hook up to these, what do I need to build into my system, we can help you with all of that. So we can help you with integration work. We do that with customers very regular. So if it's in the UK, we tend to actually get the customer's product into our workshop and we help them with integration. So if we're integrating, say, 6 or 8 packs in some applications, fitting in the BCU, we'll help them, we'll design brackets, we'll help them with the cable design and layout to get the customer up and running as fast as possible. And we'll help if that's remotely in Europe or in North America or APAC. Wherever the customer is, we're always on hand to help either in person or remotely to help you get these installed. In a lot of cases, it's more or less plug and play. You know, it is fairly simple. There are things that the customer does on their side on things like pre-charge. They're more application specific. So, you know, we tend not to kind of offer those, but we could certainly help on advice on the kind of electronic control boxes, the contactor, part numbers, specifications for those, and certainly we also have a list on our website of approved chargers that we would recommend. Again, if you want to use a charger that's not on that list, come and speak to us and our applications team will help you through that process. So looking at the time, we've had 45 minutes now. I think we wanted to leave a bit for Q&A.
Yes,
so
sir.
that's me. That's us done on the Turnside modular battery packs. So,
Fantastic. Thanks so much, George, for a great presentation. As we begin to take questions, please continue to ask more if you have them. We'll get to as many as we can, and if we don't get to some, we will post it in a Q&A blog with answers. So, George, our first question is, are 44-volt batteries low enough voltage to not need HVIL and be touch safe? Also, are they low enough voltage to be connected directly to chassis ground, like a basic automotive 12-volt battery, or should they be isolated from ground like a high voltage EV battery? 2 questions.
Oh, I missed the first part of that question, if you could read that out.
Sure. Are 44-volt batteries low enough voltage to not need HVIL and be touch safe?
Yes.
Okay. And then are they low enough voltage to be connected directly to chassis ground, like a basic automotive 12-volt, or should they be isolated from ground like a high voltage EV battery?
No, so in the low voltage, they're absolutely fine if you're below the 60 volts. Now, as I mentioned at the beginning, these can be connected in series to build them up in multiples of 44 volts. So if you were building bigger systems, then you have to look at the system architecture, and that would be when our applications engineers would actually help the customer on their specific application. So they'd look at the layout, the design, the system voltages, the current, what we needed to do for earthing and grounding. So very much engage with our engineers. When it's just single modules, absolutely fine, no issues. When you start connecting in series to build bigger voltage systems, please consult with us and we'll help you through with that.
Excellent. The next question is, why was the metal casing a better fit for this battery than a plastic casing?
Yeah, so initially in the slide deck, I actually showed, so we started off with a plastic enclosure. Our last battery pack that we made, the Gen 4 system, that was manufactured in a composite case. So we started off, we had every intention of having a plastic housing. But it became increasingly difficult looking at the battery regulations to be able to comply with the thermal propagation. So as much as we tried, we were almost there with the 4.5. We could have actually wrapped up the modules, we could have put on fireproof coatings on the inside of the plastic to get that to pass. But then cost was actually becoming a bit prohibitive. So we actually just went back to looking at an aluminium housing. So it did actually penalise a little bit in weight, but it made sure that 100% of the time it passes the propagation test. So again, it's very robust. We can bolt straight to the housing in this. So yeah, we just had to transition. It was really due to that thermal propagation that we changed. We've kept the 2 packs the same. As I said, the 4.5 was close, but we did have random results sometimes. So what we need to make sure is that we don't just get a random pass and in future we maybe get a fail for some reason. So when we looked at, yeah, we penalised a little bit on weight. Frankly, from a price point of view, there wasn't a great deal of difference. And we know 100% that these pass all of the fire propagation tests and that they're absolutely robust. So that's why we moved to metal case.
So the next question is, are there different sizes of the BCUs for smaller applications, or is it one size fits all?
No, that's a very good question, actually. There are actually 4 variants from memory. for different voltages and for different system configurations. So I think when you're above 250 volts, there's a different part number. So if you're building a high voltage system, there's a part number. If you want a high voltage interrupt loop, there's a version for that. So again, on our data sheet for the BCU, it makes it clear the part number and what that version does. All of them go in the same box, so we don't make it any smaller. We've just settled on that box size. But there are 4 different variants depending on your application. So good question. Thank you.
Excellent. Well, that is all we have time for today. George, thanks again for the informative presentation. We are so appreciative to you being here. Attendees, thank you for joining us as well. This webinar will be available on demand in about 48 hours. We hope you'll join us for our next webinar and hope you all have a great week. Thanks again, everyone.
Okay, thanks again. Thank you.